So now that we have a bit of a foundation in Pythagorean theorem, let's practice some problems involving calculations. So let's look at a first example. Now, as a good rule of thumb, whenever it is that you're looking at doing some math calculations, make sure that you read the text that explains what it is that you're supposed to do, because sometimes you might mistakenly answer the question correctly because you haven't found what they're asking you to find. So be sure first to read the beginning part of the question, the words, so that you know what it is that you're supposed to be doing. All right, so let's begin. Whenever it is that we're looking at a triangle, a right triangle, and you know that you have to use Pythagorean theorem to solve this problem, the first thing you should identify is which side of the triangle is your hypotenuse. And so when I look at my right angle right here, I look right across from it and I know that there's my hypotenuse. So I always like to remind myself where the hypotenuse is. And once I've done that, I can start to work through the problem. So I first like to write down Pythagorean theorem because that reminds me what tool I'm using. So here we go. So c squared is equal to a squared plus b squared. So remember that this c squared right here, that has to be the hypotenuse. Okay? Nothing else except for the value of the hypotenuse or the unknown variable representing the hypotenuse can go in the place of c in that formula. Okay, so let's carry on and fill in what we know. So it appears that c is my hypotenuse, and so I'm not going to fill in any numbers there because I don't know what the hypotenuse is. That is my unknown, so I'm going to leave that as c squared. Okay, so it doesn't matter which of the other two sides, whether it's the 9 right here or the 7 that I call a or b. I'm just going to choose, so I'm going to choose to put the 9 as the a and the 7 as the b, but I could have made it the other way around and that would have been fine. So I'm going to plug in or substitute 9 wherever I see a in the formula. So 9 is a, so 9 squared, and b is 7, so 7 squared. And now I'm going to clean it up. I find that I do better in solving problems and I make fewer mistakes if I clean things up as I go. So in Pythagorean theorem questions, I like to remind myself that c is still squared, and so I continue to write that on the left-hand side so I don't forget about it. So 9 squared is 81, and 7 squared is 49. Again, I'm going to clean that up. So c squared is equal to 81 plus 49, and so that ends up being 130. And so some people will often stop at this point, forgetting that you haven't actually found the length of c. This 130 over here, right here, really represents, you know, c squared, but not c itself, right? So that's important to remember. And so I need to find out what c is. And so since c is squared, I perform the opposite operation, which is to take the square root. So the square root of c squared will give me c all by itself, because the square rooting undoes the square. Whatever I do to one side, I do to the other side. And so the square root of 130 is about 11.4 units. There aren't any units indicated, but I want to mention that it's a length, so I'm going to just use the word units there to indicate that. Sometimes the question will tell you where to round to. I've chosen to round to the nearest tenth of a unit, but the question might specify something different, so it's important to read what the question's asking you about that. Hopefully you didn't find that too difficult. What we're going to do now is move on to a second example of this type. All right, so in this next problem, we're going to up the ante a little bit. It's going to be a little bit more challenging. Right off the bat, when I look at which side is unknown, okay, that's this side right here. So when I look carefully, I can see that here's my right angle, And so the 14 is actually my hypotenuse.
Mr. Ontario, could you come to the office, please?
Thank you, Mr. Conway, for intervening in our lesson. Moving on. All right, so let's get rid of some of this here. Whoa. And start labeling. So the 14 is my hypotenuse C. I'm going to call this 7B, and I'm going to call my unknown side length A. So moving on. So let me write out the Pythagorean Theorem just to begin. It keeps me organized. And I'm going to fill in what I know. So in this case, I actually know the value of C, and it's 14. So I'm going to substitute that in. Now, the fact that the 14 is on the left-hand side actually makes it a little bit more complicated of a question, but hopefully we'll explain it and it will make sense to you. I don't know what the value of A is, and so I'm going to keep it as a variable. And I'm going to substitute in the value of B, which happens to be 7 in this question, so 7 squared. Okay, let's clean that up. If you're not sure what 14 squared is, then make sure to use your calculator to figure that out. It ends up being 196 when I say 14 times 14. I still don't know what A is. I'm working towards that. And I do know that 7 squared is 49. Now, what makes this question more complicated is that I need to somehow get this A squared all by itself on one side. Now, what that means is that I need to be able to get rid of this plus 49. So to get rid of plus 49, I can take away 49. But in order to make sure that whatever I'm doing that the left side equals the right side, I need to do the same thing on both sides of this equation. So I'm going to subtract 49 from the left side as well. Now what that will do is give me simply A squared on the right-hand side, and then the 196 subtract 49 leaves me with 147 on the right-hand side, on the left-hand side rather. Okay, now remember that I haven't found out what the length of A is yet, because I still have 147 being equal to A squared. So I'm going to take the square root of that. Whatever I do to one side, I'm going to do to the other. And when I do that, I get the value of A as being approximately 12. I'm going to make that 12.1. And there are no units with this question, so I'm just going to write the word units in to remind myself that it's a length and it's a measurement. All right. If you need to watch this video again to understand some of its components, feel free to do that. Otherwise, we're going to look at another example that I'd like you to try on your own.